Welcome to this special holiday edition of the AI show. In the United States, it's Thanksgiving, so I thought we could all be thankful for the following 3 segments we have for you today. Number 1, some folks asked some pretty good machine learning questions, so I thought I would share the goods, a bit on how machine learning works, as well as some of the mathiness of regression. Thing number 2, remember when Craig came on and blew our minds with the new Linux workflow with WSL? I do. If you don't, then this will be segment number 2. He walks me through how to set up WSL in a special way with VS Code. It's bananas. Thing number 3, the incomparable Cassie Breviu took over the show a couple of weeks ago and showed us the PyTorch Profiler in action with Sabrina as her special guest. 3 amazing segments, 3 cool things to learn, 3 ways to spend an awesome Friday. Let's start with me waxing poetic on how machine learning works. From Milo, machine learning file output. Great question. So let's go over here and let's go to Reveal in File Explorer. You're probably wondering, well, what the heck does machine learning output? So let me just here. I'm gonna turn this because I'm gonna say this in like authoritative and put some inspiring music behind. Hold on. I gotta go full screen here. Machine learning is the process of extracting functionality from data. I'm going to do that again because this is super important. Super important. Here, I'll put this corner thing out there. Machine learning is the process of extracting functionality from data. That was touching. So if you think about it, what does that mean? Like if you're a programmer, you're like, well, there's a Python file I run, or if you're a .NET or a compiled language person like Java or .NET, or there's a jar file, an assembly, or some .exe file that's been compiled. There's a file. Basically, machine learning makes a function that it's squozing out from data. So Milo, to answer your question, I'm going to open the file and show you what it produced. It's this. In here, you'll see that something comes in, and for us, this is RGB pixels, so that's 3, and this is height, and this is width of an image. Notice channels are first, and then what happens is math happens on it for a little while. Blap, 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 blap. Until the end. By the way, this is a small network, which is great because then it'll run faster. I hope. And at the end, we get this vector of size 4. And this vector of size 4 has a number in here, another number in here, and another number in here, and another number here. And the one that's the highest tells us the index of the thing we need to guess. And the thing we need to guess is one of these index. This would be index 0. This would be index 1. This would be This would be index 2, and this would be index 3, right? And so that's what really is going on. The machine learning file output for this particular model is a graph plus some numbers that it uses to multiply the pixels by. So that's it. And you're probably wondering, well, are all machine learning models like that? Yes. They're all numbers that do math stuff. And I said maths for our international audience. In America, we only have one math. I got to ask my friends in other parts of the world, like in India or the UK, what the other math is. But yeah, Brian, a single function squeezed from data, it helps contextualize it. Yeah, it does. Because now as a developer, it's like, oh, this is like an assembly or a jar file that encapsulates functionality with its helpful files, right? That's all it is. And the thing is, and I'm going to go on, maybe I should let's go on our soapbox one more time. Making it more than that is eating fried froth. The volume is there, but the content isn't. And once you think about it like that, like it makes a lot of sense what's going on. And then all of a sudden, ML Ops. Here's another question. That was a great answer, though. Is it possible to encode psychological expressions? Well, I mean, if there's a picture of a person and they're happy, right? It basically takes those pixels, and then let's just say there's another picture of someone and they're sad. Basically, it takes those pictures and does the same thing. So it's not necessarily encoding facial or psychological expressions so much as it's encoding how to multiply pixels by numbers to put numbers in other vectors to do predictions. Okay, so they kept asking me about regression. Okay. Let's see if I can elucidate here. So basically, imagine you have a series of points here that maybe look like a line that would go through here, right? The goal out of this is that if we get a new point green, like we get a new point X, we predict this point right here, right? So that's what the linear regression is. And the reality is that the distance between these lines here, right? This distance between every point is the thing we want to minimize, right? So this line, you've probably seen something like y equals mx plus b, right? Everyone, oh yeah, can I show my screen? Yes, sorry about that. I was supposed to be showing my screen. My bad. So let me go back to that. Thank you, Brian. And I might need to go like Google with Bing real quick. So let's just say you have a bunch of points like this, right? So these are a bunch of points here, and then what you want to do is when you get a new point, so these are the x values, and this is the actual predicted values, right? So when you get a new value x, let's just say right here, you want to find a function such that when you give it x, it predicts y according to this kind of thing. So that would put it squarely around right here-ish, right? So we want to predict that. And the reality is that you want to create like some kind of line to do that, right? Now, again, pretend this is in multiple dimensions, right? So if you're in 2 dimensions, it's basically this. If you're in 3 dimensions, it's a plane. If you're in 4 dimensions, it's a cube. You know, if it's in 5 dimensions, it's a hypercube. If you're in 6 dimensions, it's a hypercube, all the way to forever dimensions hypercube, because I guess they ran out of things to call it. I mean, I don't know. Yes, explain regression. Yeah, I'm doing it. Okay. So everybody remembers from school that the line is y equals mx plus some bias b. In this case, we're trying to find the right m and the right b. Let's do away with this for a second because you can see that I've centered it around the origin. The b value makes it so that this line can like go up here, for example, because now that this is the y-intercept, right? With matrix math, we basically say y, which could be a vector, equals w, which is a matrix transpose times x, which is a vector, plus b, some bias, right? And what we want to do is we want to find a way to measure how bad we are at it. You could totally do that. I'm such a goober because I just remembered that I have like this entire space here that I can use this with. So let me turn this on here. Use my pencil again. All right, here we go. Okay, there it is. So I'll draw this because the thing about these drawings is I've been saving them. And so here, let me move this. And so if someone wants to do that, and I'm gonna over here just bring up the normal equations, by the way. Normal equation. Because I want to make sure I'm not lying to everybody. You know what I'm saying? Okay. So again, here is the graph. Here is the points that we know are in there, right? And notice it has some kind of linear thing. This is the line we want to learn. Oh, jeez, that was terrible. Control Z. This is the line. I know there's a ruler there, but I'm not going to use it because I don't want to. This is the line we want to learn. Remember that the equation that we have is y equals mx plus b. In vector land, it's y equals w transpose x plus b, right? Because this basically is like a system of linear equations, right? And so what we want to do is we want to minimize the sum of the differences between the left and the right side. So let's just do away with this, right? So we basically have y equals w transpose times x. And there's a couple of things that you can do. If you want to so let's just say you want to solve this iteratively using just regular like gradient descent, for example. Basically, what you can do is you can come up with a loss function, w transpose x plus b, right, minus the actual y value. And then what you can do is you can sum over all of the x values, and then you can square it. Basically, this here is the function that we're trying to learn. Remember this function f of x. So we get f of x minus y. This is called the L2 norm. Now, the cool thing about this is you can actually use the gradient with respect to the variables w and b of this to find a way for calculus to give you the actual answers. So I know I went and did a lot of mathy things real quick, and I feel bad. Maybe I should have prepared more for this to show you. But basically, we're going to let me do gradient w of b of w transpose x plus b minus y L2 norm. And when you take the gradient with respect to these, you start to get some values of how to actually minimize the error, because this tells you the error. For example, if we guess 2 and the answer is 1, then this becomes 1 then squared. If the answer is 3 and it's 1, notice that this becomes worse. So this is called the loss function. Now, basically, the cool thing is if you use calculus to iteratively diminish the loss, you basically get a value for w and a value for b, which then you can use in the function to do prediction. So that's what regression is effectively. Okay. Any more questions about? I know this kind of looks scary, and everyone's like, "What the heck? I thought you were just some goofy talk show host." I am a goofy talk show host, but secretly I want to be Tony Stark. I'm not gonna lie. Can you show how the gradient maps into all of this? Can you run it in your code? Says Brian. Yes. So let's talk about the gradient here, and let's just ignore the bias variable. So the gradient of w with respect to w transpose x minus y quantity squared, right? And let's just change this to a sum, w transpose x minus y quantity squared, because then it becomes easier. And when you take the gradient with respect to w, the 2 goes out in front, right? You get the sum of w transpose x minus y times the derivative of the inside, which in this case is going to be x. So let me move this up. So the gradient with respect to w of this function, of this loss function of w with respect to w and b, but I took out w, basically becomes 2 times the sum of w transpose x minus y times the quantity x. And let me show you what that looks like when you run it in code. So let's do github.com, and we're going to do I have some really cool notebooks that show this. So let's find it. Oh, there it is. PyTorch intro. Or maybe it's deep learning with PyTorch. Deep learning with PyTorch. It doesn't let me find it. So deep learning with PyTorch. Okay. So I think I have some numbers that show you how to do these things simple. Here we go. So we'll load this up here. Here we go. So notice this is one way of looking at it, but you can see right here that I'm doing a similar thing, but I'm doing it for classification. But notice that this is the loss function that I was talking. This is the model function. X transpose W transpose X plus B, W transpose X. I don't have a B because I don't have a bias in this case. Notice that's the model function. Notice the loss function is the square of H minus Y mean. Remember we had that in there before. And now notice that when we do the update, the gradient is 2 times X dot H minus Y over N. And then we update the W and we do this in a loop. And again, I wanted to show this in a non-deep learning. This is all just using straight NumPy. Let me make sure that my math was. I think my math is correct. So the gradient with respect to that is 2. It's actually 1/2. 1/2 sum, right? The derivative of the derivative of the outside. So you bring the 2 over. So that would be W transpose X minus Y times the derivative of the. Why is this? Oh yeah, no, this is right. This is right because this H represents this X transpose. So this is H minus Y. Exactly, perfect. And then over N, right? Because that you're doing the sum over N. That's what the 2 bars is L2 norm. And so notice that right here in this for loop, we're basically, when we get the gradient of this function, we're basically subtracting off the gradient with a learning rate. The W is a matrix, right? Because it's a multi-value. So yeah, so it's a system of linear equations that we're learning at the same time. So Brian, hopefully this answers your question. This is actual code that does the right thing in this particular case. And so it's the same thing that basic, by the way, this H, if you're wondering, is W transpose X and minus what, see that? And so that's exactly what we're doing. And so this case, it's using it for classification, but in the other case, you're doing it for regression, and that's how you do that. Okay, cool beans. That was a little extemporaneous multivariable differential calculus for the win. All right. By the way, if you want to go to this, it's super handy. Notice that it learns exactly what you would expect it to learn, which is cool. And this is my dumb 9 square problem to explain classification. Maybe we should go through this one day because this is super helpful to understand what is actually. And this is not using any deep learning framework. This is using just straight NumPy. Boop. Okay. Brian, did I answer your question? Any other questions about regression, by the way? Because dude was super excited for regression, or lady. I don't want to. Okay, now back to work. How'd I do? Is machine learning clear as mud? Next up, Craig shows me a better dev workflow with WSL and VS Code. Take a look. Craig, how you doing, buddy?
Hello, how's it going? I'm doing well. How are you?
Good. So we were on an email thread a while ago, and I was like, this stuff doesn't work for AI. And you're like, wait, no, Seth, when's the last time you looked at it? And then I was like, 18 months ago, which then you informed me that in computer dog years, that's like a decade ago, right?
Yeah, exactly. And we're talking about the Windows subsystem for Linux. So I am a program manager working on the Windows subsystem for Linux at Microsoft. And yeah, it has changed a lot. We've done some really cool stuff behind the scenes, and I'm really excited to show you the kind of the new workflows that we've unlocked in the latest updates.
Okay, so first of all, if you could give us a little splainer on what WSL is. I did a video on it many moons ago. It's absolutely amazing. Why don't you give us like the 10-minute spiel? Let me put your face on the whole way so everyone can see you. 10-second spiel.
So 10 seconds. The Windows Subsystem for Linux, or WSL, allows you to run Linux command line tools, utilities, applications, and workflows all directly on your Windows machine. So you don't have to have a traditional VM setup where everything's totally separate. You can access your files across Windows, across Linux. You have full interrupt. You can even run PowerShell.exe straight from a bash shell, which is mind-blowing. And it's just a way to have it fully integrated environment. So if I'm a Linux user, I can access all my PowerPoint, Office tools, and Photoshop as like a front-end dev, perhaps. And if I'm a Windows user, I get the whole wide world of Linux to play with.
I believe in audio terms, it's this.
Yes, exactly.
Like if WSL had its own like walkout music, it'd be.
We should do that on every startup. You start up the terminal.
They should, yeah, every time WSL starts up. Okay, so the reason why this is cool for me is because particularly in AI, the workloads tend to be mostly Linux. Like there's certain things that like the Cocoa tools. If you don't know what Cocoa is, the Cocoa data set is the one for object detection. Like that library doesn't even work. Did I say library? I'm so sorry. This is how, like I didn't know that I was going to embarrass myself in front of the PM.
I'm embarrassed for you.
Yeah, library. That library is built by Microsoft, and it doesn't really work on Linux. I'm sorry, on Windows. And I've always wanted to do this, but I started using WSL like many moons ago. I'm not trying to grab him there. That looks weird. Many moons ago. What's better about it now that I've totally missed the boat on, and you're going to show us?
So if you've seen WSL way before, we actually had a translation layer, and it was a really cool implementation where everything ran on the Windows NT kernel at the end of the day. We've improved that by switching to a virtualization-based approach, and we actually use a real Linux kernel built by Microsoft and shipped via Microsoft Update. So if you hit like update and check for updates on Windows settings, you get a Linux kernel, which is awesome. And one of the cool things that we do with this is because we have virtualization, because we have real Linux running in the background, we can do like Docker containers. In Windows 11, we have access for GUI app support. We also have access to your GPU for AI and machine learning workflows.
We have to hold on. I gotta. That was the thing that I struggle with, because when it comes to containerization on Windows, I could never access the GPU, which is super struggle bus for me when I was trying to do AI workloads. Could you talk about that a little bit more, and then get to the rest? Because I want to make sure we do a little stop on that one.
Yeah. So basically what we did is it's actually a really cool change. We made a kernel change in the Linux kernel to add a device under /dev, and it's called the DXG device. And it is a device that basically forwards any GPU communications to your Windows GPU. So if you're used to using like a virtual machine, sometimes you have to directly assign a GPU to that. This is even cooler because you don't assign your GPU. It just works when you have the right drivers installed, which are like on Windows 11. They're automatic. And it also shares your main GPU on your machine. So I only have one GPU on my computer. I can use it both in Windows, like while I'm using Windows, and then be training on it simultaneously.
What? He's all like, I only have one GPU. We all do. I mean, I feel like the ones that have more than one are. One day I'll have more than one. I'll live in a smaller house though, but that's how it works. That's really cool. So one of the other things that's interesting, and this is the part that really like super got me excited, is that there's a way to actually develop on containers that now have GPU access to the GPU access through the Linux kernel. I need to draw a diagram.
Yeah. So basically, yes. What you can do is you can take your WSL instance, run a container in it with access to the GPU on Windows on your machine, and then you can develop directly inside of that container using VS Code Remote. It's a really cool workflow.
Whoa! And see, that is the part that I was like, because imagine a scenario. Because the reality is, whenever I do machine learning workloads, I'm testing stuff locally in order to make them run in the cloud. But anytime I make a mistake in the container, I'm talking like 20 minutes before I even know that I forgot another pip install.
Yep.
If it's local, a lot of these huge images are cached, and now your dev cycle is a lot faster. And so if you're running a container environment, if it works there, that container will work in the cloud as well, right?
Exactly. Instantaneously. And you even get F5 debugging and all kinds of tools. So it's really, really neat.
So I thought you would help me with this. So what is it that I need to do to make it work? I installed a couple of things that you told me to. This thing, and then I think I had this thing installed. So, and I say this thing. Let me make sure everyone can see. This thing, and then this thing. Can you tell us what this one is, and then what this is?
Yeah, so this is VS Code, and on the right is the first one at the top is the remote extension. I was pointing to it on my screen, and I was like, no one can see that. And the what it allows you to do is when you click it, you can access remote instances and debug directly inside of them. So you can access things like your WSL distros directly. You can SSH to remote machines, and you can even access containers directly inside of it.
Oh, okay. And then this thing over here is just the standard Docker container thingy.
Yep. Just to look and manage what containers you got running.
So I'm going to open this one first. I have Azure registries. These are the containers that are in Azure ML that it manages, and then these are the containers that I have. Like for example, Torch Vision for a CPU. And this is just what this does. Now over here, this is the question now that I want to see if I can figure it out. I ran something yesterday. I didn't know what was going on, and I thought we would start from scratch to get our Rochambeau project. And let me show it to you here. It's basically this trainer. If I say Python, let's see, Python trainer minus config. This basically, oh geez, conda activate torch. How embarrassing! in front of the PM from WSL.
I like your prompt, by the way.
Oh, thank you. Yes,
this is line.
Yeah, I know. Isn't it beautiful?
Very
this tells
gorgeous.
me what environment I'm in. This tells me where I'm at, etc. Do you know a guy by the name of Ben Hillis? I think he works on your team.
Yes, I know Ben.
I was his TA in college. Did you know that?
Yeah, he told me that. That's so funny.
It's weird. Like I was doing an interview with the WSL dudes originally, and he's like, "Hey, Seth," and I'm like, "Hey, how's it going?" And I'm really excited. He's like, "I was in your class," and I was like, "What?" Oh, Ben. Oh that's no, funny. This is broken because I broke something. But let's break it inside of a container. How about that?
I'm all for it.
So let me go. Let me see. Maybe I can find the line where it's broken. Dang it. Because what happened is we broke it last time and I didn't do anything about it.
And fit.
Oh my gosh. Line 986. Oh geez. Oh geez. Oh, I know what it is. Something is not the right size here, I think. Let me see. But let's do this. Let's get the container to break. Let's get it to break in the container, because if we get to here, that means that it's running. And then I'll figure it out later. I don't want to waste time. All right. So I want to make a container. So obviously I need to have a container definition. What do I do? What do I push?
I would hit Shift Control P.
Shift Control P.
You're going to bring up the command palette and then just type in, there it is. Remote containers add development container configuration files right at the top.
See, I did it like last night, but again, I was tired. So I don't know if I did it right. So Control Shift P. I hit this. The workspace could fail to open container. So should I not do workspace? Should I just go to the actual project?
I think so. Yeah, I think that'd be easier.
Right. Let me try that. That way I can work on stuff separately. All right. CD Rochambeau AI echo dot.
Yeah, because it's going to make a .dev container definition.
Okay.
So what we're actually doing is basically making one folder, and it's helping you set up the files in it. So if you hit Shift Control P, bring that up again. Yep.
Okay.
And then there's a bunch of different definitions here. We can just choose any. I would just choose Ubuntu for now, and then we can go in and change it.
What if I have my own like Docker? What if I can make my own Docker container? Like if I can do a Docker file, would that work?
Yep. So it's just going to give you like a default Docker file, and then we can put in whatever we want after that.
Okay, so should I just choose Focal?
Actually, wait, let's go back and see if they have like choose your own. Perhaps they have that as one. I've always just used the sample. Show all definitions, perhaps?
Show all definitions?
Because I know they do some magic.
Bazel Debian. Oh, Docker from Docker? Oh, no. Docker in Docker?
Yeah, I would just choose Ubuntu, and then we can play with it. With what they have.
Oh, there's so many.
Yeah, there's a ton.
Oh man, there's so many. This is cool. So I'm going to do Ubuntu, and then we're just going to change it to whatever we want. Focal.
Yeah, that works.
Okay.
So it's created two files inside of a folder. Created .dev container, And then this is what VS Code looks at. So it looks at this dev container.json. And basically it's saying, what's the name of your instance, right? At the top is Ubuntu. What does it build from? Dockerfile. And we pass in some arguments to that. So like this focal argument. And then we can pass in settings, extensions, and all kinds of different things like post create commands. So this is where all the VS Code hook-ins, or I guess plugins come in. And then if you click on that Docker file, here's the Docker file that it's building from. So that's all.
See. Well, why don't I feel like, because if I'm understanding this right, this here is going to add a bunch of extensions in the container for VS Code for me to work with, right? So basically running VS Code inside of the container. Is that right?
Yeah, that's exactly it.
So let me see, Control-Shift-P. Since I'm doing something in Python, okay, continue. Will it get mad at me if I make another one?
I'll probably just overwrite it.
Let's just do this. Overwrite.
Yeah.
See? This is nice. I figured that would be nice because the reason why is because there's a lot of Python things that I use.
Yes.
And so if I do this, it'll give me all the Python stuff that I want. Like this is everything I use.
Yeah, that's a great call.
Okay. So there's the Docker file. Looks like it changed this. Yep. Here's a question. Because I know I have some dependencies that I need to install.
Yep.
And then I also know that I want to base it off of this image.
Got it.
So let me see. Let me try something. So let's see how good my Docker-ish isms is. So Control A, delete from this.
Yep. That looks right.
Okay. And then I'm probably going to need this conda dependencies file.
Yep.
So let me move that over here. And let me just change this to something smaller. So conda, yellow. And I'm going to take this stuff out because this is Azure ML stuff and I don't need it.
Got it.
I don't think. So there's that. Okay. So now I'm guessing it's just here. What do these args do?
So the args, this is what it's passing into the Docker file. So if you go to the Docker file, you can see that we're passing in the args. We deleted it, but they would come in as like environment variables. Yeah, you can see variant there and node version. So we can basically delete those with impunity at this point if we're changing everything.
We're doing our own thing. So I see. So there's the variant, and then okay.
Yeah,
that makes sense. So what I'll do is I'll go back here, Control A, Control Z, Control A, and then I'll say from this. Oh, I need to go back and copy it. So from this environment, this is the container I want.
Yep. And
again, I'm trusting you on because this is a GPU based container.
You can trust me.
I'm trusting you. We're going to do this. So because of this, I'm not going to need these args anymore, right?
Yeah.
So I'll take that out. I'm going to need to copy the conda.yaml over to, I don't know, just the current directory.
Yep.
And then run. Now this is the part. Okay, this is the part I always get confused about. Okay, install conda. Install packages from conda file. Google this with Bing. Here we go. Look at that. We'll just use that.
Easy.
Stack Overflow coding. Huh? There we go. Blessed day. And then we'll do the base environment since it's in that way it'll just run. Yep. And then we're going to use conda.yaml. Oh, oops. Now, is it with an A or without an A?
Without an A. At least your file is.
I know, but what is the right way? Should we be putting A's in there?
I don't know. That's a question for the broader community.
Oh, thanks. So people are telling me on LinkedIn the screen is blurry. I'm so sorry. We're also on YouTube. I don't know why it's blurry there. I'll have to go check the settings. But we're on YouTube, and if you go to twitch.tv/Seth Juarez, you'll see it too. Sorry about that. I'll check that next time. Okay. So, anything else I need to do? Like, is there any magic sauce of things that need to happen?
There's one more magic piece.
Okay.
When you're creating a container, you pass in an argument to say that I want to pass my GPU to this container. I want to access it. So in this case, we would basically make a new line in the dev container.json file.
So like right here.
Right here. Just make a new line. And then we're going to add like if you hit the quotes and then type in like run args, it should autocorrect. Or double quotes, sorry. And then type in run args, and I'll even tell you. There we go. Cool. And so now we're passing in basically like strings that we want as run arguments to our container. It's the exact same as if you typed in Docker run these arguments.
Got it. That makes sense.
So, and then we type in -- GPUs equal all.
GPUs all.
Equal all. And then there's an equal instead of a space. Yeah, exactly. Okay. That's it. And then now because we're going to be running this in Linux, right, from WSL, because that's where the Docker instances are, then it's going to pass in your Linux GPUs, right, which equals your Windows GPU.
I see. So is there anything else I need to do, or is that literally it?
That should literally be it. I think you're now all set up.
So this will basically set up the environment for me in a container, run with a GPU, have VS Code all set up, happy for me with all of these things. So now what?
So now what? Hit Shift Control P, and then to open your command palette, and then do open in a container. So type like open, and then space remote. Remote.
Open remote.
Oh, what's the command? Let me look it up.
Is it this thing over here?
Oh yeah, we could click that as well. I usually open it straight from the command line.
See, that's because, again, genius. So there's this. Is there? What am I?
I got it. It's type in reopen in container. That's why.
Reopen.
And then space. Yeah, in container. So then there's an option rebuild and reopen in container. See it?
Yes, here.
2 more down.
1, 2. This.
Yeah. Remote containers, rebuild and reopen.
Okay. So I will do that. Control Shift P. Reopen in containers. So we're gonna do rebuild. Is it rebuild without cache or reopen?
I would do rebuild and reopen in container.
This one.
Yeah.
Okay.
Yep. That's one that I use.
Things are happening. Here we go.
Shut down the instance. VS Code is opening it up. I would hit show log. It's really cool. Okay. And this is where all the magic that VS Code is doing is happening.
Is this opening in the container?
Yep. It's built your container. It's opening it, and it's doing a really cool Docker run call, connecting all the pipes to VS Code, and then it gives you an error.
Did I do something wrong?
Unable to find user VS Code. No matching entries and passwords.
I have an idea.
Yep.
I'm guessing, and you tell me what you think. By the way, we went back to I said open. There is no user VS Code, right?
Yeah, we can access that. And then we can use the root user instead. And that should be fine.
By the way, this is cool. It's actually showing me, oops, Control Z, I messed up over here. It's actually showing me what happened. Cool.
Yeah.
So go over here and just comment this out.
Yeah, I would just comment that out.
Okay, cool.
And then we can run as the root user.
All right, Control Shift P, and then I'll do this again.
Yep. So that's what's cool about it is like the container, let's say you had some other error, right? Of, some other Docker error or something was wrong. Anytime that happens, you can see exactly the error. You see the full logs from Docker, and it just makes it a lot faster. So you don't have to push to the cloud and then go, oh, oops.
And the reason why this is going a little faster, my friends, is because I actually tried this in a different project and I kind of made it work. And so now I'm glad you're here to explain stuff to us. And so it already cached the big image.
Yep.
Oh my gosh, what's going on here?
Maybe
I'm doing something wrong. Okay.
It looks like some Docker thing. But there you go. We're there.
So now I'm in the container.
Yep. And you know how you can tell really easily?
How?
Look at the bottom left of the screen. You see dev container Python 3. That's how you know.
Oh my goodness.
Yeah. And so if you click that, you can reopen locally. You can rebuild your container.
Where does this name come from?
I think that comes from the dev container file at the top.
I can. Okay.
Yeah.
Okay. So I can be this can be like the Rochambeau AI, container.
Yeah.
Okay. Well, let's try it again. Control-Shift P.
Also, my other favorite thing about this, so I use the Vim extension in VS Code because I love the Vim, keyboard shortcuts.
Sure.
All of and you didn't notice this because it's so seamless, but all of your normal extensions propagated to the container. So your theme didn't change. It's not like you're running on a totally different machine.
Right. Like that's the thing, and that's the thing that's kind of magical.
Yeah.
Is that I am sitting here opening it. I'm like, oh, this is just Visual Studio Code, but it's not. It's Visual Studio Code in a Linux container.
Yep. It's running entirely different, right? It's running entirely on a different machine. It's running even in a different operating system than where the UI is running for this, but all your extensions stay the same. For me, my Vim extension stays the same, so I program the exact same way, no matter what environment I'm on. It's really cool.
Oh, look, there's the name. Look at
there we
go. some branding we got going on over her. Man, dang it! I missed my calling here. I just have one button to push.
Sorry, I got it.
So cool. Oh, so whatever happened last time? Oh no, it still has something.
Something's going on, but that's fine. It doesn't seem fatal.
It's like the Jupiter. Is it? I think it's trying to, yes. I think it's trying to open like the Jupiter thing, and it's just I can't do that. We're not using Jupiter.
The Jupiter tooling's failing, but that's fine. It's not causing anything.
All right, moment of truth.
Crash. All right, well, we hit the same error.
Python. It's like we're trying to hit the same error.
Will it almost work?
Will it almost work? Config. Config. Okay, here we go. Things are happening. Life is good. We want the same error. Same error. Here we go. I feel like I need to put some like dramatic music. Here we go.
Oh, it's building. Oh, what else we should do is open the task manager, and you can see it hit your GPU.
Oh, hurry. Task manager. By the way, it's going to break, so
that's fine. We'll see if it assigns memory.
Oh, look at it. It sees it. You're like, it says 0, Seth. No, we're counting in computer science.
It's happening.
Oh my gosh, you got the same error.
All right.
It's perfect. Wait,
it almost works.
Hold on. Look at that.
There we go.
Oh my gosh, this is so exciting. Look, and you have no idea. And look, I'll be honest with you. A lot when you're using like container-based training, a lot of your time is spent, I got to rebuild a Docker container. I forgot this pip package. Doing this locally and making sure it's doing the right thing and then using the exact same Docker file is legit fantastic. Oh, so anything else I'm missing? Well, let me try. Let me see. Let me open this up. Here's another question.
Yep.
Like when I'm working on this, where is this file writing to?
Yeah, so it's doing a bind volume mount to your actual file. So if you go back to that .dev container, you can see how it's doing this. Okay. And then scroll down a little bit, and let's see. Or maybe it's up. I'll have to take a look at mine. But it basically will mount your actual where your workspace is. It will mount it to the same as your what you're developing.
Is it this thing? Because I saw this. This is by the way, this is a Docker desktop, which I have a license to now. I purchased a license because their licensing is different now. This is legal. I am all legal. So basically VS Code mounts the volume. Is that right?
Yeah. So it's essentially it's the exact same files, right? In the exact same place is how you can think about it.
And this is what this is doing. Okay.
So the one up there, that container is running and it's accessing that volume. And it's basically, so all your files are in sync in step.
So Loving Allen is running. This is all happening inside of Loving Allen right now.
Yes. Yes.
I wonder what their name generator. I've always wondered how their name generator, because that is fantastic. Okay, so that was the other question. This is all basically running off the same file system. Now, the other thing, and here's a question that I wanted to ask you because this was super interesting to me. When I'm in File Explorer, there is this new this thing. What is that?
So it's our friend Tux, the Linux penguin. Do you know Tux?
I know who it is. I know it's Tux. But what is going on there? What is going on there?
So this is a WSL feature. When you enable WSL on your machine and you install distro, we put this inside of your File Explorer, and you can access your Linux files directly from File Explorer. So if you click on it, there's your distros. You can click on Ubuntu, and then you can fully go through your root file system totally in File Explorer. Where this is really cool is we have another feature called WSL -mount.
Okay.
That lets you mount other disks on your machine that are formatted in ext4 or like Linux file systems. So let's say I had a drive on my machine and I was dual booting, right? I was dual booting and I dual booted to another drive that had all my Linux stuff. You can actually mount that into Windows now through WSL and then go look at it through File Explorer.
What?
Yeah, it's really cool.
A black hole when you're like, oh, I got to boot into Windows today instead of booting to Linux. It's not a black hole. You can totally mount it and take a look at your ext file stuff.
Yeah, exactly.
That is bananas. And this here, are these the containers? What is this?
Yeah, Docker Desktop creates two distros to house its container data, basically. So those are the two distros where all the containers live and all the runtimes for the containers live. As an end user, you don't really need to worry about them.
Because you told me I had to go click this, right?
Yeah, so that's the default now. If you install Docker Desktop, like nowadays, you'll get this by default. But if you're using an older version, perhaps you'll need to go to Settings and then click Use a WSL2 based engine. And then now everything is running in WSL2 in the backend.
And then the last question I have is, GPUs are so finicky. Is there something that needs to be installed for it to work properly, like the way we just did it?
Yeah, so there is basically, there are changes that need to be done to your GPU driver to make this work. And so what that is you basically need to go install a specific driver. If you're on Windows 11, this just comes by default. So on the latest versions where this is, it'll just be by default one of your drivers. However, if you're on the Insider program right now and you're using things and you don't see your GPU, I would basically just go install it. The easiest place to go find it is if you go to aka.ms/WSLG. That is our place where we have our GUI app repo. Yeah, that's it. And we have our link to the drivers there right at the top. So installing WSLG, there are the drivers. So the NVIDIA, and there's also Intel and AMD because we support DirectML as well. So you can do training on non-NVIDIA based GPUs as well.
Hold on.
Yes.
You almost beat me on that one. Wow, that is pretty cool. So if you have a Windows device and you have an Intel GPU and an AMD GPU, because of the DirectML hardware layer, did you say DirectML?
DirectML, yep.
You're able to do all this stuff as if you had an NVIDIA GPU.
Yep.
Dang. All right. Is there any question that I should have asked that I didn't?
Let's see.
I mean, I feel like this was pretty cool. I mean, setting it up, I'm glad I recorded it so I can remember for the next one. Because having this is going to save me a lot of time. Because how many dev containers can I have in a single project? Just one?
I'm pretty sure you can make multiple kinds. I'd have to go look. I've only ever used just one.
Okay.
But also you can basically just copy this setup that you have and paste it. So let's say you make another machine learning project and you're like, oh, I want that exact same machine setup that I had for this one. Just paste it. Then you have the exact same Docker file. Everything works. It's exactly the same setup.
Will it cache this too?
Yeah, so it basically builds a new container each time. So the layers of the container that you're using will be cached. I don't know if like you're probably going to hit new layers because of what you're running on, but at least the base image and what it's building on top of will all be cached. Yep.
This will be cached, but not this.
I don't know for sure. Potentially, depending on how Docker slices
All
it.
I know is this happens super fast.
Yep.
I need to figure what this is. I don't know what I'm doing wrong.
It looks like one of the extensions that we're choosing is just not loading. We probably just have tons of extensions that aren't set up, like the Jupyter one. That's my guess.
Where's the Jupyter one? Let's take it off. I think I know.
I'm not sure.
It's the Jupyter thing is installed by default in the Python stuff.
Oh, okay.
But we'll figure. It's probably trying to get out of the container.
Yeah.
Cool. All right. Well, this has been amazing, my friend. This has been super enlightening. I'm glad that we've had a chance to look at these and how to do this. And it feels like a better workflow all around. Where can people go to find out more other than WSLG?
So if you want to find out more, the best place is to go to aka.ms/WSLDocs. That has everything and anything WSL, from getting started to best setup guides to how to use Docker, to all our tips and tricks. And if you want to follow the latest WSL news, you can follow me on Twitter. I'm at Craig A. Lowen, so CraigALoewen.
Oh, we're gonna get Craig A. Lowen. Did I get that right?
I can't see, but probably.
Hold on, wait. Is this? Oh, you can't see because I'm not showing my screen. Here's the docs, by the way, that I brought up and no one saw. This right here.
Oh, there's an E after the LO. So LOEWEN.
LOE.
Yeah, it's
low.
German.
Yes.
It means lion.
Am I following you? Why am I not following you?
Oh, embarrassing, Seth.
Follow. That was sad. Look at this. Linux on Windows, totally. All right, my friend. This has been super amazing. Thank you so much for being with us, bud.
Thank you very much. Thanks for having me. And have fun coding everything and anything Linux on Windows.
I think I'm going to change my whole workflow, man.
Sweet. You should.
All right,
that's what I do.
All right. We'll see you soon, bud.
Thanks. See ya.
Take care. Bye. How's about Craig blowing our minds, right? Next up is Cassie and Sabrina and the PyTorch Profiler.
Hello, everyone, and welcome to the AI show. I am Cassie Brevu, filling in for Seth Juarez, and I'm super excited to be here with you today. We're going to be talking about PyTorch Profiler and Onyx Runtime Web. And the cool thing about today is it is the Friday before Halloween. So hopefully nothing too spooky happens on our stream today. Okay, and so I am going to bring in our guest, Sabrina. Welcome, Sabrina.
Hello, thank you so much for having me. Thanks so much.
Yeah, we're so excited to have you and to hear more about PyTorch Profiler. Why don't you give us a little intro?
Okay, do you want the real intro or the spooky intro? What do you?
Whichever one you think. Wait, let's do the speaker. It's Sabrina, the teenage witch, right? It's like you don't even need a costume.
No, I don't. I just gotta be myself, Sabrina, the teenage witch. Awesome. Awesome. Yeah, thanks so much. My name is Sabrina Smai. I am a program manager in the AI frameworks team at Microsoft. And our team sort of primarily works on open source projects like PyTorch and Onyx Runtime. And my particular focus is on PyTorch Profiler and Onyx Runtime inferencing. So we actually partnered with Facebook on several of these projects. But I'd have to say I'm really excited to be a part of this show with you. And, I've seen the AI show many times, and it's like a huge honor to be a part of this, and especially with you, Cassie. So
the honor is ours. We're so excited. And PyTorch Profiler is such a cool product. And there's been some really great new features and a lot of really good advances there. So I'm excited to hear about it.
Yeah, for sure.
And let's see, we should look at the chat too. Let's see who is hanging out with us today. So yes, you can see through my hat because of the green screen. And so this is like an old school Microsoft hat, right? I felt like it was Halloween and it was the right time to bring it out. And because of the green and yellow, and because I have a green screen, you can see my background. And then, of course, the cat headphones I felt like were appropriate for Halloween as well. Very festive here.
And your background's on point.
Thank you. And then I really should have this one though, because I'm again taking over the AI show and becoming captain of the ship. Although I don't think I have my captain hat with me today, so we'll stick with the Halloween background.
And your sound effect on right now.
Oh, is it getting a little spooky? It was getting spooky.
It was spooky. It was too spooky for us. No, it was
too much. Okay. We don't want to scare people away. We like just started and then Seth won't let us take over his show anymore.
It gets kind of scary.
So we have someone from Ecuador. Awesome.
Oh, nice.
Yeah. So thanks so much for joining us. And with that, I'll let Sabrina take it away. Let me add your screen. There we go. Perfect.
Awesome. Awesome. Okay. Can you see my slide? Yes.
Yes.
Okay. Awesome. Cool. So I'll just jump straight into my presentation since I've already done the intro. So
yeah.
All right. So imagine that you are a performance engineer at a company, and your job is to help, identify potential bottlenecks in your deep learning system that's already in place and understand scalability issues that may occur, before you deploy a finished product. Okay. So typically, this is how you would start your day. You would begin by, running your deep learning model, capture traces along the way. And then in order for you to optimize your model, you would need to gather the profiling results, analyze them. But the problem is that traces can be gigabytes and gigabytes of data. Cassie, cue the effect.
Wait, that was the wrong one. Sorry, I'm getting used to my soundboard. Which one was that one supposed to be? Was that drama? It was drama.
Yeah, drama.
It's a lot of data.
Yeah, exactly. Terrifying. That is the problem. The problem is that traces could be gigabytes and gigabytes of data, and processing them manually can be very time-consuming and very annoying. So after you've identified the changes that you need to make to slightly optimize your model, you would need to rerun the model again, check the performance, and if the performance is great, then hooray, you're done for the day. Go grab yourself a celebratory.
Okay, it stopped.
But, and feel free to cue the opposite effect. But if the performance is not satisfactory, you're going to have to go back to step one and recapture a profile, gather the data, find out the reason for the bottleneck, fix it, and try it all over again, an n number of times until the performance is satisfactory. So this is the typical day of a performance engineer, and you can imagine how incredibly exhausting it is to go through that process an n number of times until you've optimized your model. But here at Microsoft, we actually partnered with Facebook to bring performance engineers, data scientists, framework engineers, or anyone looking to optimize their PyTorch models and bring them a tool that allows you to automatically process your traces, analyze them, and then provide automated performance guidance to optimize your model. And that tool is called PyTorch Profiler. Awesome. So I will go over the new PyTorch Profiler release, and I'll be talking about how to start leveraging this tool. I'll be covering some of the older features that we have from the previous release. So I'll be covering things like distributed training view from our previous release, memory view, GPU utilization, cloud storage support, and a really cool VS Code feature called Jump to Source Code, and then talk about some of the new features that we have in version 1.10 that just got released. So I'll actually go over each of these and quickly summarize them. So the first feature in version 1.9 is around distributed training. So this feature actually helps you understand how much time and memory is being consumed in your distributed training job. So you can imagine many issues really do happen when you take your training model, split the load into different worker nodes, try to run them in parallel so that you speed up your training. But sometimes what's happening in between that can be a black box. And your goal of applying this distributed training technique is to speed up your model training. So having a distributed training view like this will really help you diagnose and debug issues within individual nodes, which is really, really, really helpful. So the second feature in version 1.9 that we had released in our previous release is around memory view. So this view allows you to understand your memory usage better. And if you've run your Jupyter Notebook before and have done some pretty memory heavy things, I'm sure you've run into an issue or error like this before, out of memory error. And sometimes it's really frustrating. Sometimes it's really easy to pick up on why that error happened, but it's still a very pesky error to get that happens quite often. So this memory view actually shows you some active memory allocations at various points of your program run, which is really helpful.
That's awesome. I remember dealing with a bug around memory usage, and it ended up to have to clear the memory because it was actually ended up being a memory leak on an older version of a deep learning framework. And it was the new version fixed it. But something like this probably could have helped find that issue, right?
Exactly. Yeah, I think that's the most frustrating thing, is wasting so much time trying to figure it out. But if you don't have a memory view like this, you wouldn't be able to see all the active memory allocations at various points of your code to be able to find exactly what happens with that.
Yeah, I wish I had that
at
that time. Now I do, right? Now I do.
Yeah, exactly. Yeah, for PyTorch, yeah, this is a really useful tool. So the third feature in version 1.9 is around GPU utilization. And this is a tool that I personally find really, really helpful. And this helps make sure that your GPU is being fully utilized, okay? And so, oftentimes so your goal with GPU utilization is to get close to 100% utilization. And what that means is that you're using your hardware to its full extent and you are leaving no performance on the table. So your goal is to try to get as close to 100% as possible. And so having a GPU visualization like this really helps you figure out how to increase that percentage.
I suppose you could save money with that as well, right? Because if you're paying for GPU, and GPU can be very expensive, the more you're using, the more efficient it's being, and that's saving you then money on your training, right?
Exactly. Yeah. Sometimes, I've definitely had instances where we had so much hardware, and then they were all running at 20%, GPU utilization. That is a total waste, and you're leaving performance on the table, and yeah, it's a huge problem. That's why I think this is one of the most important features that could really, really help ensure that you're fully using your hardware. So, yeah. And then the fourth feature is around cloud storage support. So the TensorBoard plugin, which is a plugin that allows you to visualize some performance metrics, and that's where our PyTorch Profiler actually lives, can now read profiling data from Azure Blob Storage, Amazon S3, GCP, Google Cloud Platform. So that's a small added feature that we have that can really help.
So by profiler data, that's when it's collecting the data during training, and when it's putting that into, is it a JSON format, or what's the format that it collects in? And then that goes on cloud storage. Is that what you're saying you can do now?
Yeah. So in terms of reading in some of the data, and then it saves it into a Chrome trace file that can be visualized on TensorBoard. So now you can, it can read data from, all pretty much most of the major cloud platforms now, as of the last release. So yeah. I love that. I thought you were gonna drop a beat after. It sounds like a beginning of like a.
It does. If it wasn't for copyright, I don't have any uncopyrighted music. Otherwise, I would be so happy to drop a beat after that.
With all of these sound effects, you could make your own songs easily.
Well, you know what? I probably could use GarageBand because I've have a rig here where I'm actually using my phone to do this, and like GarageBand, you can like live mix. But I'm gonna practice before we try that. So.
Oh my gosh, our next live, okay?
Okay, deal.
Awesome. Okay, yeah. So the last feature on PyTorch Profiler version 1.9 is a pretty fun feature, actually. It's a feature that allows you to visualize stack tracing information on TensorBoard. And then when you click on a stack trace, it will jump directly into the source code where the bug is. So you can imagine how much this will help in terms of optimizing and quickly iterating through your code, based on your profiling results. So let me see if I have a video. There was a, sorry, I had a, I must, okay, yeah, let me just move this video up here. Oops.
Cool. I lowered my gain on the horn, so someone said it was really loud. Sorry about that. So I have lowered the gain, and hopefully next time.
Well, you were just making sure everyone's paying attention and awake,
Exactly. Wake up, pay attention. And also, I should say this is like I just figured out this soundboard setup, so this is totally my first trial of it. So I thank you for letting me know.
Good feedback.
Hopefully it's better now.
Awesome. Okay, cool. So the last feature in version 1.9 is jump to source code. So this is a feature, like I had mentioned. So this is TensorBoard.
Wait, we're not seeing your screen. Are we supposed to see your screen right now?
Yeah, you're supposed to see. Oop, did I lose the screen share?
Yeah, I think you got to reshare.
Okie dokie.
And then Joe Silva was asking about ML.NET or Event TensorFlow. So this is specific to PyTorch. So it's going to work with PyTorch, and I don't think it would work with ML.NET. Definitely won't work with TensorFlow.
Yeah, TensorFlow has their own profiling tool.
Good question.
Can you see my screen now? Should be TensorBoard.
Let me grab that. There we go. Perfect. Yes, we can see it now. Perfect.
Okay, cool. So the last feature on version 1.9 was around jump to source code. So this is a feature that allows you to visualize your stack tracing information. So this is TensorBoard, and all those blue links are a list of just stack tracing information. And so if I were to click on one of them, it jumped directly into the source code exactly where that bug was. So you can imagine how quickly you can optimize some of your code just based on stack tracing information, some of the profiling results that you got just in a click of a button, which is super awesome. And it's done in Visual Studio Code, and it's a fun feature to really use to quickly iterate through your code.
That's cool. So if I have my code in Visual Studio or in VS Code, and then I have PyTorch Profiler running. So this is just a tab in that. And then I can click and it's like, hey, you have an issue right here, and it'll bring me directly to the issue.
Yep. You would have to launch the TensorBoard to be able to see that, to see the screen. But yeah, if you were to, view some of the call frames, it would have a list of all your stack tracing information as shown here. You click on it and it literally splits the screen and jumps directly into your source code, which is that contributed to that bug, for instance.
That's cool. That's a new feature, isn't it? Because I've used Profiler before, but I have not seen that.
Yeah. So this was in our previous release. We just released a new release. We just had a new release about a week ago. So, but yeah, this is pretty recent. So
cool.
Yeah, super exciting. And it's fun to show in demos because it just looks so cool, just jumping to source code. So
yeah, super useful debugging. So I feel like debugging machine learning models and then hardware machine learning can get really complicated really quick. And so saying, okay, I have a leak, but where is it? Like, how do I find it? And then that's where that's going to say, here, this is where you could optimize your code or do something a bit different. So
exactly. Spot on. Yeah, exactly. So I'll actually also quickly summarize some of the features in version 1.10. So we recently released a few enhancements and a few new features. And the first one is around correlating operators in forward and backward paths. So this helps map operators that are found in the forward paths to the backward paths and vice versa. And they can actually be visualized in a trace view to have, details on 10 millisecond buckets and their states and elements and stuff like that. And then the second feature is around we enhanced our previous memory view that we already have. So this helps you understand your memory usage better, but we have additional statistics on seeing the trends of your usage and, selecting a span to be able to see some of those trends within your specified range that you've given the profiler. And then the third feature that we added in this current release is around enhancing our automated recommendation system. So this is really helpful for, getting performance recommendations to help optimize your model. So whether you're lost on how to get started on optimizing your model, or you just need a quick few actionable hints on how to really improve your GPU utilization or your memory consumption or time, or things are taking too long and you just want quick actionable steps, this automated recommendation system is a place to check out.
Do you have some examples? Like, I know there was one around workers, like how many workers you had running, but is there, like, what are some of the other ones that it can do?
So in this current release, we added a few specifically around Tensor Core and Glue, some of the new added features that we've had. But it would some of them would talk about, if your batch size is a little low, and I have a few examples in the demo that I'll be showing you in TensorBoard. And so some of them recommend like Tensor Core, and it recognizes that your GPU utilization is low, and then it would tell you, why don't you try increasing your batch size, or implementing Tensor Core, or Glue if it's distributed training, or things around your data size and stuff like that. So
awesome.
And then the fourth feature is around distributed training. So along with your ability to diagnose distributed training on individual nodes, Glue is officially now supported, which is pretty great. And then also Tensor Core is also now supported. So this is some updates on the PyTorch Profiler version 1.10.
So Glue is for distributed training, you're saying?
Yes.
Okay.
Which is now supported.
Is that PyTorch specific?
It can be, I think it could be, I know it's some of the common use cases are around PyTorch, but I'm not familiar about the other frameworks. But it's used in like the back end. But
sweet.
Yes. Okay, cool. So now to, I guess, get started, it's pretty straightforward with, getting started with PyTorch Profiler and starting to instrument your code to be able to use PyTorch Profiler. Previously, if you've used the PyTorch Profiler before, a while back, the profiler was only able to display performance information by printing a console like this that you see here on the screen. And that's after you've imported the profiler and set the console manager and turned on and off the profiling features that you want. But now, a feature that Facebook and Microsoft collaborated on is we work together on getting, having the ability to export this old console dash to TensorBoard, which is a visualization tool similar to this over here. So by adding a trace, on trace handler, the profile will start collecting all the inputs and then the traces will be saved in a Chrome trace file that can then be visualized in a TensorBoard, similar to what you see here. So the first thing you'll need to do is import Torch Profiler in your code, then set up the context manager. And this is the piece where you'll be turning on and off the features that, I had talked about, previously, like memory view or distributed training or, GPU profiling and things like that. We actually also do have a bunch of other advanced features that you can use with Profiler. So, you can specify in your context when to trigger, like, which iteration of the training or inferencing that you want to record, how many steps, information around CPU, GPU, you can specify a callback handler for results to do whatever you want. You can also get some extra metadata to enable, recording of shapes and stacks and things like that. So there's many advanced features that, we can actually, look at.
So you configure that based on your particular training scenario, what would be best for what you're using and what you're building. And then the code on the right is how it's implemented then, right? That's how you're wrapping it. Okay.
Yeah, essentially. Yeah. It's just 3, pretty simple steps, like obviously doing the pip install of Torch TB profiler, and then you can, import the Torch profiler, and then having an on trace handler. I don't know why that's a difficult thing for me to say. And so that's where, you have your context manager, and that's where you can specify, if you want to turn on memory view, you can essentially do profiler memory equals true, and then do that the same. I mean, there's documentation on how to turn those on, but it's just setting an argument to true, and you're essentially turn on the ability to use those features.
Cool.
Yep.
Thank you. Any other questions that anyone has as we're going through some of these things? Configuration questions. I think so. Jose asked, but can we use it with Torch Sharp or even Torch.net? So Torch Sharp is brand new, and I don't even know if it's in its prod release yet. I don't know enough about Torch Sharp. I think it's a really cool program, but I would guess not. Do you know if that works with Torch Sharp?
I've never heard of Torch Sharp, actually, so not familiar.
Torch Sharp is for C Sharp. It's like a API to use Python Torch library, but in C Sharp. And they actually followed all the same naming conventions that you would use in PyTorch, which I think is really cool.
Oh, okay. Wow.
Yeah, I just found out about it too. It's pretty new. That's why I think it's I don't know what version it's on or if it's even considered prod yet, but it might be.
Okay.
So I would guess, I would guess it doesn't yet because you can't use PyTorch Profiler in C Sharp. So I would say it probably doesn't, but you'd have to have some sort of profiler, Torch, Sharp, something name like that, some sort of new thing to integrate it in. But that's a really cool question.
Yeah, I mean, that's something to consider and look into, actually. So yeah, thanks for that question.
Yeah. Okay, so now we're going to see the magic happen with PyTorch Profiler. That's what's next. Anyone else have questions? Let's see. Torch serve as a model server in PyTorch. Oh, okay, that must have been answered to a different question. But yeah, I don't see any other questions.
Okay.
So we can jump in and to see how this works.
Awesome. Will do. All right. So let's we'll share.
See, this is where, should I put Seth's music back on now while we find our, or maybe I should see what some of these do. Okay, air horn was, I think, a little much is what we decided. I like this one. I haven't had a chance to use this yet.
I like it. Oh.
Did it come through?
Yes. I just realized when you put the sound effect, we can't hear when you're talking over it.
Oh, that's right. Yeah, I'll have to figure out why that is. So if I play sounds, it overtakes my audio.
Yep.
Oh, you know what? I think I know how to fix that. I'll play with it later though. All right, let's see PyTorch work. Are we ready? Oh, you have your screen. Okay, let's grab that. Perfect. Oh, there we go.
Okie dokie. Are we ready?
We are ready.
Awesome. Okay, cool. Awesome. So let's get started with the demo. So this is TensorBoard. And like I had mentioned before, this is a visualization tool that we use for PyTorch Profiler. And the first feature I'll show is actually memory view. So like I had mentioned, memory view is a feature that allows you to understand your time and memory consumption that may have caused, performance bottlenecks like out of memory errors and similar to the errors that Cassie was talking about. And, it could be like memory fragmentation issues, which had happened to me recently. And so this memory view really allows you to see, operators exactly by the name that are actually contributing to high consumption of memory and time. So in this release, one thing that we've added is this trend statistic, a graph where you can actually see some of the trends, and you can specify the range, and it will show you the trend of the memory usage events within this range. And like I had mentioned, to generate this memory data, you'll need to just ensure that you're setting profiler memory to true when you're instrumenting your code for profiler. So, and you can toggle between devices, CPU. Well, there's nothing in the CPU, right? But you can also search the operator by the name over here if you have a lot of operators. But essentially, you can just look at the size, and if things are taking a really long time for one particular operator, okay, well, you should probably investigate why that is. So the second feature I'd like to show is around distributed training.
Can I ask a question quick? So the drop downs on the side, can you tell us a little bit about what you're clicking through over there and what's available here in the TensorBoard?
Yeah, absolutely. So so these are just the runs that I've done, right? So I'll have these are when you upload a stack tracing file, it would get uploaded into here. So I had in one file, I had a bunch of stack tracing files that I just uploaded there. So they all show up here. And within those stack tracing files, there's a bunch of different views that were generated based on the context manager. When you have a context manager and turn on and off those things based on your input data, it would generate that stack tracing stack tracing file, and then you can be able to see these features. So in this particular stack tracing file for data one, demo data one, there were a bunch of features that I had enabled, and one of them was around distributed training. So that's the one that I'm going to be selecting. And then if you have workers, then it would show up here, but for this one, it does not. So yeah, good question there.
And then those get uploaded, so you can manually upload them, or do they get uploaded during training, or how, or is that kind of a configurable feature for
what are you like, uploading into TensorBoard, or?
So you said like when we have the different traces, you said you had a bunch of different ones you uploaded. So when I used it, I remember I basically set a point where I wanted it to go in my training, and then when my training completed, it automatically pushed it to that location. So
yeah, I mean, there's many different ways. I just did it
okay.
manual way because I'm not.
No, that's cool, because then like you can take those files and save them like for later too. Like maybe you're running it on your desktop and you actually are like, no, I want to put those in cloud so they're accessible. And
yes,
yeah,
exactly.
That's cool.
Yeah. Okay, cool. Yeah. So the next feature that I'll be showing is around distributed training. And let's just say perhaps speeding your model training is your goal, so you conduct distributed training. So, but debugging can be very complex and hard to diagnose without a distributed training view like this. So you can actually observe issues within individual nodes. So each of these views give you a different, different types of information that can help you, diagnose the reason for some of your bottlenecks. So this is some of the information around your GPU hardware during the run, and it would tell you, each node that's running. There's only one right here, and the hardware type and some information around the hardware. But down here, we actually also have additional statistics and information that can really help diagnose your distributed training. So, for example, let's just say if we were to take a look at this communication and computation overview, this is the time spent on either computation or communication.
Those are those spooky vibes. It's Halloween.
Exactly.
Right? Like
it's a tongue twister. So I love that. That was the perfect sound for this. So for example, let's just say we're taking a look at this overview. And so if we were to look at two of these workers, if you notice that the overlapping time, which is the red here, the overlapping time is significantly larger than another. This, to me, can suggest, okay, there might be an issue in either the workload not being balanced between nodes, or a worker is being a straggler, which can be an issue, and that needs to be investigated. So this is just how I would interpret, this overview and how that can help me to identify, okay, well, maybe there's a straggler, maybe there's not a balanced workload in all these, in each of these nodes. So that's just one example. And actually down here, there is a communication operation statistical graph here. And this table view allows you to see some, detailed statistics on, communication operations in each node, and you can, toggle between each of these. And, you can see, what operator type is being called, like, how many times is it being called? What's the size of the data that's being transferred by each of these operators, which is really, really helpful to see, okay, well, there might be one that's transferring a lot more data than the other that can be contributing to a straggler issue or something like that.
So how would you go about looking into that? Do you have any examples of that, or like maybe an example of when like that was able to help with optimization, or is it one of those things that you take into consideration and add it into kind of the whole encompassing picture to make a decision?
Decision on investigating like a straggler or workload not being balanced.
Exactly.
Yeah, I think it's just this entire picture, like just being able to look at all these available detailed statistics and being able to make a decision on, okay, well, it seems like this worker is there might be a straggler because of the huge differences between most of these, and this one seems to be kind of a bit of an anomaly. Okay, let's investigate this a little bit more, and then this is when you come down here and then select exactly that node and just be like, okay, well, the data transfer could be a lot larger, like, and you can start making conclusions on potentially what the reason is for the low GPU utilization or some of the other performance bottlenecks that you're experiencing, and then that's when you can go back and start optimizing your code to ensure that there's not an issue and improve that bottleneck.
Cool, thank you.
Yes, of course. That's a good question. Cool. So the next feature that I'd like to show is around GPU, which is an important feature to look into because sometimes performance issues are beyond memory and they're beyond node level issues, and perhaps you need to observe issues on the GPU level at every step. So let's take a look here. So this is where the GPU utilization view sort of comes in, okay? So you can see that there's there's one worker, you can tell the device type, there's some GPU summary, and for a GPU, these are the three sort of important metrics, GPU utilization, SM efficiency, and this estimated achieved occupancy. And GPU utilization is a metric around like the hardware performance. And if you want finer details, SM efficiency, if you want even more finer details, then achieved occupancy is the metric to look at. But I'll get into that a little bit later.
Okay, I was going to ask if you could tell me what SM efficiency is, but do you want to answer that now, or is that more important later when you're talking about it?
Yeah, it's up to you. But yeah, so for GPU utilization, it's a little bit, it's hard for me to explain SM efficiency without really getting into like some really like
okay, we can
topic. But yeah, so it's we can get into it. But so there's, let's see, how do I put it in? I think the main thing to just kind of understand is that there's GPU utilization, and if you are looking into getting a little bit finer details on like, let's just say, it's easier to explain on on the trace view, just because you'll be able to visually see the difference between GPU utilization and SM efficiency, and you'll be able to see how much finer details that you can get from SM efficiency based on the SMs, that can really help break down some of the reasons for GPU utilization being low or high, and stuff like that. We can get into that in the trace view, which will be, I think, next.
Okay, awesome.
Cool. So awesome. Okay, cool. So, and then we have an execution summary. So this gives you a bunch of information around, the time duration, and this graph is just a visual of this. But I think the main thing to really look at is GPU utilization, SM efficiency. These are all important metrics. So, just imagine, you have a ResNet 50 model with a batch size of 4. And this is a run that I have of ResNet 50 batch size of 4. If I were to run that and I wanted to observe some of the GPU summary, I can look at this and say, okay, well, I know that my goal is 100% GPU utilization, but I'm at 24%, which is not great at all, right?
Mm-hmm.
So, it's very low. So it is a disaster.
What are we going to do?
What are we going to do? So the natural next thing to, look at is, okay, well, it's pretty low. Why don't we look at some of this performance recommendation? So this performance recommendation does recognize that our GPU utilization is low, and it's suggesting for us to increase our batch size to improve that, and also implementing Tensor Core. So naturally, the next sort of run that I'm going to do is increasing that batch size from 4 to 32, and then having Tensor Core. So you can see that our GPU utilization jumped drastically, which is great. It's awesome. It's exactly what we wanted. So so now our GPU utilization increased drastically. There was clearly a bottleneck before, and even though it jumped drastically, there's still room for us to improve. So
that's huge, though, just by being able to look at the graph and seeing, okay, this looks weird, or like we're not using all of our GPU, why not? And then being able to make the changes and get that kind of like fine detail. That was kind of like, without the profiler, how would you know that? Or without a profiler,
Yeah, see, that's the thing is this performance recommendation is really meant to help you if you help you just kind of take quick actionable steps, and it's supposed to be a guide that's supposed to help you just quickly optimize, because that's the goal of PyTorch Profiler, is to really help make data scientists, framework engineers, or anyone looking to optimize their model, being able to optimize them in a quick and efficient way, and having all these visuals to really pinpoint exactly where the bottlenecks are. So without this, it's going to be very difficult.
Yeah.
Let's just say that. So yeah.
Awesome.
Yeah, and there's some profilers out there that do this, but sometimes the problem is that they give you so much low-level data that you're looking at it, and you don't know what to do with it. You can't really make sense of a lot of the metrics and some of the information that's being provided to you in the visuals. So having a performance recommendation system down here that's just straightforward, that just tells you like, hey, just increase your batch size. It will improve your GPU utilization, and then you do it, and your performance improves. That's pretty awesome, actually. So
super powerful.
Mm-hmm. All right. So
do you have low battery? Is that are you plugged into power? Or is that what is that?
Okay, yeah, okay. I think that might be me. Okay, yeah, good call. Thanks so much for seeing that.
I was like, I don't want to lose you. That would be awful. See, that's the spooky stuff coming back, right?
Yeah.
Okay, I like this one too, but I think this one's too scary. Right?
It's perfect for Halloween, actually.
It is. And perfect for, oh no, I'm doing a live stream and my battery is gonna run out.
Oh no, I'm dying.
That might be the appropriate sound effect for that.
Dying.
For real. Terrifying. Okay, are we good?
Thanks for saving my life. Really appreciate it.
No worries.
An applause.
Oh wait, I got to go back to the other one. See, I got to get better at these right now. I have like multiple. There we go.
This is awesome. Cool. Awesome.
Right.
Okay.
Yeah.
All right. So where we sort of left off is that we took some performance recommendations. In our next run, we took the suggestions by having Tensor Core, implementing Tensor Core to enable this mixed prediction computation and being able to adapt calculations to accelerate the throughput of your accuracy, which is exactly shown here, and increasing our batch size. So that's great. We've gotten 85% GPU utilization, but 85% is still room for improvement. So to further investigate, we can actually move to a view called trace view, which I will move to trace view. So trace view is, oops, let me just turn this off. So trace view is essentially where you get detailed views of elements in your trace and the states that they're in, and events in 10 millisecond buckets, both on the CPU and GPU side, as shown over here. And so we actually, above here, you can see that we recorded a bunch of profiler steps that correspond to our training in iterations that we have in this case. So when we look at this trace, you can see that we have these profiler steps, 15, 16, 17 over here. And if you were to zoom in, you'll be able to see some of the, you can see some of the operators under these profiler steps. And so you can see, what are the operators that are under each of these profiler steps. But sometimes it can be really hard to map them to your code. So by implementing a record function, which is adding a record function to your code, will actually make your traces easier to understand. This is part of the reason why you're able to see these operators under these profiler steps. So the first thing you typically do, when you're trying to optimize GPU utilization by looking at this trace view, is you take a look at the GPU utilization. So if we were to look over here, we can say, okay, look, yeah, you know what? GPU's not bad here, but oh my gosh, there's like an unusually like large dip And that obviously is a problem, right? So you can observe a specific area in your program where your GPU is low. High GPU utilization means that your hardware is being used to its full extent, and you're not leaving any performance on the table. There's not much room for improvement. But if the GPU utilization is low, that is opportunity to increase it. So with this, we can actually investigate this unusual dip by zooming in and exploring this region over here with low GPU utilization. So if we were to click over here, we can actually see that our GPU utilization is literally 0%. And then beside here, where we click, it's around 66.7, which is super low. But what exactly is happening here? So to get finer details, we can actually look into the SM efficiency. So if we were to zoom in a little bit.
Could you zoom your browser a little bit too?
Sure.
Would that still display fine?
I think so. Is that better?
Yeah, I think that's better. Thank you.
Cool. Yeah, sounds good. Okay, so let's see here. So so if we were to investigate a little further, we can actually use the SM efficiency, which is up here, the pink section over here, and we can observe this unusual dip and figure out the reason for all of this. So you can see that in this area, if we were to zoom in a little bit more, we have low GPU utilization, and in some of the areas that there's low GPU utilization, the SM efficiency has a lot of these micro gaps in between. It's not the same. It's not as similar as the way and how solid it is, in the GPU utilization. There's a lot of these micro gaps. It's pretty sparse, and if I were to look at this, I can possibly think that, or make a conclusion that, or an observation, and say, okay, well, possibly your PyTorch code could be looping over some vector or some data structure that you should be doing on a GPU instead. So by zooming in to, let's see, if we were to go back to this section over here to, step 16, because this is where the GPU and SM efficiency is. If we were to zoom into some of the operators in step 16, oops. Oh yeah, we can actually see it right here. You can actually see that the data loader is, the data loader is doing a bunch of iterations at the beginning of the epoch. So if we were to zoom out a little bit. So there's a bunch of iterations that the data loader is doing in the beginning of the epoch on the input data, and that is causing this GPU utilization to be low. So, and it's causing the GPU to idle. So if we were to look at, okay, so you saw step 16 and how there's low GPU utilization, we can take a look at some other PyTorch steps where these profiler steps where the GPU is fine, right? You can see that the GPU utilization is fine. Yep. If we were to zoom in a little bit, you can see that it looks pretty good from 17, 18, and 19 profiler step. And they all look good, but there might be an instance where, for example, like in this area here where GPU utilization is really high and SM efficiency is really low. There's a few instances like that. And that can tell me a different story based on this trace view if we were to zoom in a little bit. So if I were to look at this and say, okay, well, there's high GPU utilization, low SM efficiency, what sort of conclusions can you make based on this trace view? It could mean that the number of SMs are doing, the amount of work that is provided to them is quite low. And to kind of confirm that, we can actually go down to this stream 7. And what stream 7 is where all the GPU activity actually happens. So we can zoom into like this area here where the GPUs.
So you're just clicking and dragging to scroll in there?
Yeah, so there's this area here, so you can actually drag using this
Nice.
tool, and you can just zoom in using this. So if you were to zoom in a little bit, and let's just click on one of these streams and go down, you can actually see, okay, the area where the GPU utilization was pretty decent and SM was pretty low. If we were to click on one of these streams, you can actually see that the data that's being worked on is quite low, and the achieved occupancy is also quite low too. So based on this information, you can see part of the reason why the GPU utilization is low in that particular area. But that still doesn't give you enough information to really conclude exactly why that is and why is that happening. So one thing that you could do, the next sort of natural next step, is to enable this new feature that we looked into, that we released in this new feature that we released in this new
Version?
release. Yeah, this new version. Thank you. And we can actually, let's just say we want to zoom in, and there's one operator that we were interested in looking into. You can see by implementing this async GPU, it actually can map back to the CPU to see exactly which Python functions are being called and exactly which operators are being called in this particular area that this GPU utilization is really low. So we can now use those Python functions that are called in the areas where the GPU utilization is low and figure out exactly how to improve it, whether it's to do it to have it on a CPU instead, or a fused kernel, or any other technique that can help improve that on the CPU with these Python functions or PyTorch operators. Yeah, and I think the last thing I'd like to show is that there's another feature that we added as well around backward and forward pass. So let's just say, there's a problem in step 18. So I think this is step 18 that caused like a low GPU utilization. And we can actually see that with implementing this flow event backward forward, if you were to zoom in a little bit more, there's quite a few of them. But if there's a particular problem with one particular area, you can see that the problem's on the forward pass, which is the left side here, and it's actually replicated on the backward pass too. So you can use this information and really be able to take that, track it back to the CPU, and investigate exactly, how to optimize that in your code. So there's just a lot of, can be a very complicated, it can be really complicated, but there's steps to kind of take to make sense of some of the bottlenecks that you can have and really, really dive a lot deeper into this. And this is part of the reason why this is the first time really doing a demo on TraceView on a deeper level. It is a little bit complicated, but if you spend the time to really understand some of the features that are available around TraceView, you can really, really nail down exactly where the bottlenecks are that could be hard to diagnose in general. So I think that's it for my demo here.
Is there documentation to help with that part for the PyTorch Profiler, or is there resources that you would recommend for people to kind of use to better understand some of the information that they're able to get?
Mm-hmm. Yeah, so in my slides actually, and I had a few extra slides, but we are at the hour mark. But
You can go over if you want. It's totally fine. I think we can.
Okay, maybe I'll like snag like 5-10 minutes.
Yeah, absolutely. Go for it.
Okay, cool. But we do have references to answer your question. There's references
Okay.
at the end of my slides that we
Fantastic. I got ahead of the game.
Awesome. Yeah, you did. Cool. So I'm guessing you can't see my slides yet.
Does anyone have any questions on the demo there? Seeing some of the ways, the different parameters that you can get some of the diagnostic informations and how you can kind of zoom in and get more information. Any questions on that? No? So everyone's so quiet today. Okay, I need a crickets sound effect. I don't know where it is. Maybe I have one, but I have to work on like making favorites here. But all right. Oh, did we lose your screen again?
Should be sharing.
So someone's asking if PyTorch Profiler is TensorBoard.
No. That is a good question, and it can be very confusing, actually. So TensorBoard is a visualization tool that other profilers actually use too. So PyTorch Profiler, a few years back, was a profiling tool as well, except the only way that you would get your profiling information is through a console dash looking thing. But recently we just realized that, this console manager was not really, it wasn't nice enough. It didn't have all these nice graphics that you see here. So what the collaboration between Microsoft and Facebook is that, we work together on exporting this old console, just by doing a print statement to be able to save these inputs into and then the traces in a Chrome trace file to be able to visualize on this tool called TensorBoard. So if you were to do a pip install of TorchDB Profiler to be able to use the profiler, it would need to be in conjunction with TensorBoard to be able to see these nice visualizations. Because I think if you just install PyTorch, you're just going to have to use that console. And that's the older version, AutoGrad, older version. But the new version of PyTorch Profiler is using and visualizing your Chrome trace files on this TensorBoard. And that's how you get the pretty nice visuals.
And I have a question on that too, because I think you had it open in the browser and you had it open in VS Code, right? So I can open it in either location?
Yeah. So the way that I like to use it, you can open, because it's a Chrome trace file, you can open it on the browser. You can open it on the browser and just by, just by typing like TensorBoard and log directory and then bind all, and you'll be able to get, if you have it on your desktop or something like that. Yeah, you can just upload it and like using localhost. And yeah, there's many different ways of using cool. It, but there's documentation on the different ways of doing it. You can even have it from what's it called, Blob.
From Blob Storage?
Mm-hmm.
Okay. So that's cool. So I know we saw like a lot of it in VS Code, but I want to make sure it's clear. It's like TensorBoard. You can use in VS Code. You can use it in lots of different ways. And then,
yeah. I think that as long as you have a Chrome trace file, you can pretty much upload it to or use it with TensorBoard. So that's however way you get there is completely fine.
Cool.
Awesome. So I think the last few things I'd like to talk about is just quickly over some of the integrations that we have, and then looking into some of the upcoming features that are pretty exciting. So one of the integrations that we have is with PyTorch Lightning. We also have integrations with Kubeflow pipelines. And this is, if you see here, this is actually an end-to-end integration of a BERT model view where you can run your pipelines in Kubeflow and you'll be able to directly jump from there to see the TensorBoard with Profiler right there in the pipeline view, which is super cool. So that was an interesting integration that we have. So down the road, these are a few things to kind of expect. Like we are hoping to add module level views and some more information that can really help you diagnose your bottlenecks and be able to optimize your model a lot quicker. So a few to look into that are pretty interesting that are upcoming. Like one example is Python function tracing. So sometimes when you look at a trace view, there could be some gaps on the CPU side. It looks like nothing's happening. So, you're probably thinking like, what's going on to lead to CPU being idle, which a lot of profilers don't have. This essentially gives you what's going on as long as you're using Python, and it will give you all the function calls to be able to help diagnose exactly what are the issues. And then we also have coming up, we also have a module view, which is pretty cool because, again, in Chrome Trace, you get a lot of low-level Python operators, but sometimes you can't even get the module name. So this module attribution feature maps the time consumption in the modules in your Python script, which can be very helpful. And then the last one I'd like to highlight is around graph visualization, which is a sneak peek on a feature that we're working on to help visualize your PyTorch models in a graph form, which is really helpful. So I think to end off, these are a few references on how to get started, to see if there's certain scenarios that you have around PyTorch Profiler to see if it's a good fit. We have a bunch of talks that we've done on GTC, a bunch of profiler recipes, like quick getting started, some PyTorch Lightning samples and PyTorch Kubeflow samples as well. This is a few references.
That's awesome. Is there any like GitHub links or Get Started links? Is that also in there as well that we could you send me those and I could paste them in the chat? Or actually, I think I might have your presentation too.
Yes, absolutely. Actually, I just realized the GitHub link is not on here. So it should be GitHub Kineto.
Let me see if I can find that one.
Well, that's the most important.
So it's not the PyTorch /profiler. That's not the right one?
No, it should be Kineto.
Oh, I see it. Okay, perfect.
Yeah.
I will paste this in the chat.
So the profiler, I think that GitHub is like the older version of PyTorch Profiler, AutoGrad. But then Kineto is the PyTorch TensorBoard profiler.
Okay. So that's why it has kind of the different name.
Mm-hmm. Yes. So the new one is the one that you get the cool visuals and not printing a console. So
I need to get a second two computers, and so like the one that I can chat on is over here. So I'm just going to be off screen here for a minute. Well, this was awesome. This was super helpful because I've used Profiler before, but I haven't used any of like the new features, and it looks like there's been a lot of enhancements, which is awesome, and a lot of cool ways to dig down into your deep learning model to kind of like understand how you can better utilize your hardware and make sure your trainings go faster, which saves us all time, right?
Exactly, yeah.
And then I think you showed some code earlier. It's like, isn't it like 3 lines of code to add it? Or like, it's not, because like one of the things when I see some of these tools, I think about, okay, that's really cool. How long is it going to take me to actually add it and use it in my project? And I think I saw that it was like just a few lines of code, right? You just like wrap your training.
Yeah, it's essentially 3 steps, and obviously importing the package and then having that on trace handler and then having that a context manager, which you wrap your code in, and that essentially allows you to just turn on and off things and then have a a piece step. So in your actual training code, you'll need to just add a piece step where the loop happens, and essentially that's about it. And then you'll be able to use TensorBoard and profile and find some bottlenecks in your PyTorch model. So yeah.
Okay, this was all awesome. Thank you so much for coming to this special holiday edition of the AI Show. Coming up next week, Azure Machine Learning Batch Endpoints with special guest Tracy Chen. Make sure you tune in. See y'all next time on the AI Show.